My name is Jamie Farrell. I'm a seismologist at the University of Utah. We operate the Yellowstone Seismic Network. Over the last 3 years, we've been doing some work at the Upper Geyser Basin around Old Faithful using these smaller seismometers. This is one of them right here. This little thing right here has everything in here that we need to record seismic data. So there's what we call a geophone in there that's monitoring ground movement in all three directions, north, south, east, west, and up and down. It has a battery. We just basically spike these things into the ground, and we put up to over 500 of these things in the area. They're very sensitive to ground movement. One summer, we put in just a few stations to see the difference between summer activity and winter activity. We put a few stations in, and this one in particular that was up on Geyser Hill. So this is away from Old Faithful. It's very quiet at night, which is what we would expect. And then during the day, it slowly ratcheted up to higher and higher noise levels during the day. But I noticed this sawtooth pattern. It was going up and down. And I plotted timing of Old Faithful eruptions. You can see this noise level from people walking around the boardwalk. It would build up, and then once it got close to an Old Faithful eruption, it would die down because all those people moved away from this station over towards Old Faithful. And one of the more interesting ones we found is this pool up on Geyser Hill called Doublet Pool. And it doesn't erupt or anything like that, but in 2015, about every 40 minutes or so, the pool would start to bubble and get agitated, and then the surface would start to thump up and down. And if you're really quiet, if you're sitting there on the boardwalk, you can literally feel and hear these thumps. And interestingly enough, in 2017, we noticed something different about Doublet Pool. So not only was it happening more often, it was happening about every 29 to 30 minutes instead of 40 minutes in 2017, but each episode was lasting about a minute or so longer. But really the focus of these experiments we've been doing has really been Old Faithful. So we've done 3 different what we call campaigns around Old Faithful. So each one of these occur in early November after the park closes. So the first year, 2015, we put in about 133 stations. In 2016, we came back and we did something a little bit different. We did a much denser array around Old Faithful. And then in 2017, we came back and did more of a general array around Old Faithful, and we moved the dense array up to the Geyser Hill area, and then we did a bigger footprint across the whole Upper Geyser Basin. If you look at the seismic signals recorded around Old Faithful, you see this kind of general buildup of what we call hydrothermal tremors. The seismic signal for the actual eruption is much smaller than this pre-play. And what we figured out that we're seeing here is that, as Old Faithful is building up towards an eruption, the underground plumbing system is filling up with this superheated water, and you have these bubbles being formed. They reach the top of that water column where it's relatively cooler than where these bubbles were formed, and they implode. And when those bubbles implode, that creates this seismic signal that we're recording. If it's the same every time, or if there's some predictable decay on that, then there is potential for us to really be able to predict Old Faithful eruptions very accurately, probably within less than a minute. One interesting thing that you can do with these really dense seismic networks is you can look how these seismic signals travel through this area that's covered by these seismometers, and we can really look and see what's going on as these seismic signals travel through the Earth. As we saw that there was this one area just basically to the west of Old Faithful, where it was consistently delaying seismic signals as they traveled through. We interpreted that as this underground reservoir of hydrothermal fluids that's feeding Old Faithful. And what we found is when these seismic signals travel through this body, it's not this open body of water underground. It's really just a series of probably fractures that are filled with hydrothermal fluids in this area. But those fluids, the presence of those fluids changes the way these seismic signals travel through this area. And what we see is that once these seismic signals travel through here, they kind of get trapped in this area. They just bounce back and forth and reverberate. And keep in mind, these are very small signals. You can't feel these yourself. These are very small. Only these instruments, these very sensitive instruments, can see these. And so this can really tell us about, if there was a larger earthquake in the area, say like Hebgen Lake, 1959, those seismic signals that travel through this same low velocity body and get trapped. And that has implications for seismic hazards in this area. So the Old Faithful Inn is sitting right on top of this body. And in fact, the Old Faithful Inn was damaged by the Hebgen Lake earthquake. Some of the large rock chimney collapsed. This coming fall, this November, we're going to do similar types of experiments, only we're going to move to Norris Geyser Basin. They're in different geology, these two geyser basins. The other thing is Norris is one of the hottest areas in the park, and it's also very dynamic. There's always new features popping up here and there, and also Norris Geyser Basin is home to one of the tallest geyser, active geyser in the world, Steamboat Geyser, which actually has just erupted. If we get lucky, maybe Steamboat will erupt while their instruments are on the ground. That'd be very lucky. But in Yellowstone is the location of some of the largest, what we call hydrothermal explosions in the world. And these things happen every year. And most of the time they're small and they're in the backcountry, so they're not a hazard to people. But they have happened in front country geyser basins before. And what happens is these hydrothermal systems, these kind of nutrient-rich waters are coming up from underground, and they erupt and they form these really cool pools and stuff like that. But they're also depositing these minerals as they come up through the plumbing system, and sometimes they clog themselves up. And that pressure builds up and builds up until it releases in what we call a hydrothermal explosion, where you're releasing hot mud, hot water, hot gas, and then rocks that blow out. And that can be very dangerous to people if it happens, close to the boardwalk. So if there are any kind of seismic precursors to one of these hydrothermal explosions, and if we can record those and then we can identify those, we can look for those in real time. One thing I really like about working in Yellowstone is it's a very active and very dynamic system. We record anywhere from 1,500 to 3,000 earthquakes a year. Sometimes there's gaps. Sometimes we get these earthquake swarms that we call, where you get a lot of earthquakes in one area and for a short period of time. Just last year we had what we call the Maple Creek swarm, where we had over 2,500 earthquakes located near the town of West Yellowstone, and many of them were felt by people. Honestly, every single year we learn something new about the Yellowstone volcanic system, and that's the fun of it.